Hi, this is Purnima and you're watching video lecture series on power system protection and switchgear. Today in this topic, we are going to discuss about the apparatus protection. Which apparatus we are going to discuss is motor. So protection of motor. Come, let's go to the video. Here comes why protected motor power system is needed. Why the motor need to be protected. So main thing is energy consumptions and cost of failures and production impacts. So main three things it is. So motor consumes approximately 65% of the industrial electricity worldwide, making their protections critical for operational efficiency. So cost of failures, the fault can causes costly downtime, extensive equipment damages and serious safety risk to personnel. And we have on protection impacts. A single motor failures can halt an entire protection line, resulting in thousands in lost revenue per hour. So that's what the motor need to be protected. Here coming to the common failures in protected motor power systems, we have an overcurrent and short circuit, phase fault and ground fault. Here the overcurrent fault. So excess current flows causing overheating and insulation damages leading to motors. Coming to the short circuit, you have sudden low resistance path causing massive current surges can destroy motors in milestones. Coming to the phaser failure, so one phase lost or voltage unbalances motors run on three legs and burns out quickly. So that's what phase is very important. Balancing is very important. Now coming to the ground fault, here coming to the current leakages to the earthing creates an electrical hazards and potential shocking risk. So these are the common faults in the motor power systems. Coming to the key protection device for motors, what are the protection devices? The fuse and thermal overlay, and we have magnetic contactors, and we have protective relays, etc. So fuses, thermal overload relay, magnetic contactors, and protective relays. These are some of the protecting devices which protects the motors. Coming to the types of switchgears in motors, we have an isolators, we have an switches, we have a few switches, we have an circuit breakers, we have isolator which provides safe electrical isolation for maintaining but can't break load current safety. So just isolate, but it 100% it can't break the load current safety. Coming to the switches which can make and break load current but not designed for fault current interruptions. Now coming to the switching, fuse switch, so combining switch capability with fuse protection in a single compact unit. And finally coming to the circuit breakers, can make carry and break both load and fault current safety and repeatedly. Here coming to the curious hint, it is vacuum circuit breaker is exhaust arcing in microseconds using the insulation property of vacuum. Now coming to the how protection works through the strip circuit. So here comes what happens. CTS PT sends the current or voltages. If it is it exceeds the preset value, what happened? Relay analysis that it exceeds the preset value. If it is exceeds the trip coil energized, once it energizes, what happens? Circuit breakers gets opens. So this is the first stage, this is what second stage, and this third stage, and finally fourth stage circuit breaker opens. At the protection scheme, that's what they are given. The current potential transform sends the motor current and voltages, which protection relay analyzes and signals abnormal conditions. The relay closes the trip and energizes the tripping coil of the circuit breakers, and circuit breakers opens. And finally what happens? Enticing the protection scheme can act as an intelligent guardian, continuous monitoring, motor health, and response installation of the failures to the failure. Now coming to the overload trip relay characteristics, we have inverse time time characteristics. What happened, it is we have an class 10 and class 20. What about class 10? The relay tripping time between 2 to 10 seconds at 7.2 into rated current. Coming to class 20, what happened, it takes to 4 to 20 seconds. So we can see the difference. What about the class 10 and class 20, how fast it is tripping. This class 10 and this is what, an class 20, it timing. What about it take how many seconds timing. Now coming to the coordination of protection scheme, here we have an selectivity, we have an device coordination, here we have an backup protections. So these are what about the coordination of the protections here we have seen. So here coming to the real world example, which have a manufacturing power plant production. The protection scenario, it is the manufacturing plant uses squirrel cage induction motor, which represents 90% of installed motor, which is worldwide, with the compensated protection schemes. Here we have four types. It is a normal condition, normal operation, fault detection, rapid response, and finally success. So this is what the real world examples. And we have a normal operations, motor runs with thermal overload, relay contactors and MCCB motor continuously, and first phase impulse triggers the protective relays, and circuit breaker trips within zero point 0.5 seconds, isolate the motors, and motor saves for winding damage, and protection is main thing. And finally, coming to the summarize, we have now many circuit breakers, which is air circuit breakers, vacuum circuit breakers, SF6 circuit breaker, and integrated protections. By using these protections, the motor can be safely operated, and most of the low voltage protections use up to 690. Here, ultra fast arc excisions we can use vacuum circuit breakers used in medium load applications. We can use in SF6. It is solid state soft starter. We are using integrated protections. So I hope now you understood that protection of motor. Will meet in next class. Thank you so much.